The other part of the section on solving radical equations is dealing with extraneous solutions. And an extraneous solution is something that works out mathematically, but when you go to check is kind of irrelevant. If you think back to the problems we did with the factoring, and we wanted to find the fence of a garden, and we got an answer, and one was negative. We disregarded the negative answer because you can't have a length or width that is negative. So it's kind of the same idea, but it doesn't matter if it's negative or positive for this case. It's just you'll get it, but it won't work out. So we'll take a look at some of those examples. So the first thing we're going to do here is we are going to take both sides and we are going to square. We want to get rid of that square root, so you must square both sides. And this is where the extraneous solutions are going to come into play, when you have to square or square root both sides. On the left side, we'll have x plus 1 times itself, x plus 1, because that's what x plus 1, the quantity squared, is equal to. The right side is just now 7x plus 15. We have the radicand. From here, we are going to take this part and we are going to FOIL or do a generic rectangle, whatever you prefer. We should get x squared plus 1x plus 1x plus 1. So it's x squared plus 2x plus 1 is equal to 7x plus 15. We are going to now combine like terms. We're going to bring 7x over and 15, and I'm going to bring them over at the same time. So now we have x squared minus 5x minus 14 equals 0. So from here, we are going to factor this out. We're going to do a diamond and set the parentheses equal to 0. Okay, so we're going to factor it out. So if you want to do a diamond, we need two numbers that multiply to give us negative 14, but add to give us negative 5. That's going to be negative 7 and a positive 2. So we have x minus 7 times x plus 2 equals 0. So that means x is equal to 7 and x is equal to negative 2. So we are going to check to make sure that both of these work, and we're going to plug it back into the original function, or I'm sorry, the original equation, which is x plus 1 equals the square root of 7x plus 15. So if we start with the 7, we'll plug 7 in, so we have 7 plus 1 is equal to the square root of 7 times 7, which is 49, plus 15, so this will give us 8, is equal to the square root of 64. So 8 does equal 8. Now, when we go to do these, we are only taking the positive answer. So here, we're not going to say plus and minus 8. We've done that in the past, but for this to work out appropriately, we have to take the positive answer. So that's true. That works out. Now we're going to try x equals negative 2. So we'll have negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. So that would be negative 1 is equal to the square root of 1. So negative 1 is not equal to 1. So x equals negative 2 is an extraneous solution. Both of these work if we plug it back here, but if we plug it back into the original, only the x equals 7 is going to work. So 7 would be our solution. So again, we have the extraneous solutions because we're taking the square or the square root of both sides, and that's going to throw off some of our answers. All right, the other example, this is number 8 from the notes. We are going to take the square root of x plus 2 and then add 1, and that is equal to the square root of 3 minus x. So we're going to start by squaring both sides. And now what is unfortunate about this problem is that the left side does not, the squared and the square root do not cancel out because you have that plus 1 there at the end. So we actually, when we square it, we will have two square root of x plus 2's and then plus 1. The right side, the radical does get eliminated, so you are left with the radicand of 3 minus x. So over here on this left side, we are going to multiply them, and we're going to start, I'm going to FOIL, so I have the square root of x plus 2 times itself, which is squared. And then I'll have plus the square root of x plus 2, plus the square root of x plus 2, plus 1 equals 3 minus x. So what happens is these two are going to get put together, so that will give us 2 square root of x plus 2's. This, the square and the square root will cancel each other out, so we have x plus 2 plus 2 times the square root of x plus 2, and then plus our 1 is equal to 3 minus x. We can combine like terms, so we have x plus 3 plus 2 times the square root of x plus 2 is equal to 3 minus x. So what we're going to do is we're going to subtract 3 on both sides, and those 3's cancel out. And then I'm going to bring this x over to this side. So that leaves us with 2 square root of x plus 2 equals negative 2x. So both of them have a 2, so we're going to divide by 2. So we have square root of x plus 2 is now equal to negative x. And now we're going to square both sides. When we square both sides, over here on the left, we'll have the radicand, which is x plus 2, is now equal to negative x times itself, which would be x squared. We're going to bring the x and the 2 over. So now we have x squared minus x minus 2 equals 0. And from here, we are going to factor it out. We can do a diamond. We need two numbers that multiply to give us negative 2, but add to give us negative 1. So that's going to be a negative 2 and a positive 1. So we have x minus 2, x plus 1. So x is equal to 2, x is equal to negative 1. And then we want to check. And again, we're going to plug it back into the original problem, which is the square root of x plus 2, and then we have plus 1 equals the square root of 3 minus x. So if you plug, we'll start with 2. If we plug 2 in, we'll get the square root of 2 plus 2, which is 4, plus 1, equals the square root of 3 minus 2, which is 1. Okay, so this will give us 2 plus 1 . 2 plus 1 is 3, and then over here we'll get 1, which is not equal. So 2 is an extraneous solution. So now we want to check to make sure that negative 1 works, so we're going to plug that back in. So we have the square root of negative 1 plus 2, and then plus our 1 is equal to the square root of 3 minus a negative 1. So on the left side, we will get the square root of 1 plus 1 is equal to the square root of 4. So we would be left with 2 equals 2, which is true. So our solution is going to be x equals negative 1. So negative 1 would work, but 2 would not.